Implementing Forefront Identity Manager 2010, Module 2, in which we cover the Synchronization Service and the Synchronization Service Manager, the tool that's used for managing the Synchronization Service. In Lesson 1, we talk in detail about the Synchronization Service, covering the key principles, concepts, nomenclature, and so on. FIM is a state-based system. There are advantages to this, particularly robustness, as well as potential disadvantages in the form of extra processing and storage, but the actual result is a very effective and flexible compromise. FIM stores a binary object called a hologram for each external object about which it knows. This hologram represents the current state view of the data stored in each data source. During a subsequent import of data from the data source, the state of the imported object data is compared with the previous known state. If any differences are detected between the two, for example, if the value for the job title attribute didn't match, or if there was a completely new object or a missing object detected, a change is inferred and the change is handled by the sync engine and propagated through the meta directory if appropriate. Exactly the same kind of idea is used for export. Changes propagated through the meta directory are compared with what was understood to be in the data source previously, so that a set of exports can be generated. The same idea is used during export confirmation. Re-imported source data is compared to what was exported to confirm that it got there. In a deployed system, MA runs are invoked by scripts, which are either run on a scheduled basis or possibly in response to external events. Perhaps an HR system could invoke a run to ensure that a recently terminated person has their account disabled urgently. So FIM asks for data. It's a pull system, and this avoids the need for a push agent on each connected data source. However, FIM can work with delta imports of only those objects that have changed. And as it happens, by the way, exports are always deltas. Some data sources support this already. Others may be able to with some modification, yet others simply can't support this feature. Where deltas can be used, there are considerable savings in processing time, but if required, FIM can work entirely with full imports. This minimizes the intrusion on data sources. Sometimes it's also necessary to use a full import anyway, for example when recovering from a data source or SQL Server store or connectivity failure. This architecture does involve some additional storage because FIM keeps a hologram for each data source representing the real-world object, in addition to the combined metadirectory representation it has to keep anyway. But it is very robust in the sense that a communication or storage failure will usually only require fixing the immediate problem and restarting the process of checking the states of all objects in all data stores. Okay, in more complicated disaster recovery situations, that needs a little bit more careful handling and thinking, but it is true for many simple failures. FIM is not about real time. Few metadirectories are. The answer to the question of how up to date is the data depends on many factors, including the processing power available and intelligent configuration. Some implementations will require that data can be processed as fast as it is changing. In other situations, overnight processing may be perfectly acceptable. Another positive feature of a state-based system is that business rules are enforced persistently. The simplest way to explain this is by example. If an account is supposed to exist for a new identity, it is provisioned. If it subsequently becomes arbitrarily deleted when it shouldn't be, then provided FIM has been appropriately configured, it will detect that the state has changed and again enforce the business rule by reprovisioning it. This equally applies to an account being disabled. If that's the intended state, FIM can ensure that it stays in this inactive state. The primary FIM components are the metaverse, connector space, the connected data sources, and the management agents that connect to them. A connected data source, or sometimes just a data source, or even just a source, is a data repository that contains identity data to be integrated within FIM. Sources could be enterprise directories, network operating system directories, databases, or data in flat files such as LDIF or DSML or delimited text. A management agent, or MA, manages the data associated with a specific data source. The MA not only connects to the data source, but is responsible for managing the flow of data inbound and outbound, and for interacting with other MAs. There is at least one MA for each data source, and usually only one for each data source. For many MAs, FIM communicates directly with the data source. These are call-based MAs. For others, an intermediary file is used, such as AVP, LDIF, fixed width, delimited, and so on. These are known as file-based MAs. Call-based sources are highly preferable. File-based MAs are usually only used as a last resort when there's no other way of connecting. In some cases, the situation may be more complex. There may be no MA specifically for the data source. The data source may, for example, support a mixture of file and call-based activities, so that no standard MA turns out to be suitable. The extensible connectivity MA allows a developer to handle such situations by creating the code that can handle almost any data source. The extensibility connectivity MAs are not covered in this course. The Metaverse is a set of tables within the FIM Synchronization Service database that contains the integrated identity information from all the sources. All identity information about a specific person or object which is stored in these multiple connected sources is synthesized into a single entry in the Metaverse. The connector space is a storage area and a staging area. It contains the holograms, the states, that are used to decide whether information in a data source has changed or needs to be changed. It is also where changes are staged on their way into and out of FIM. Each data source has its own logical area in the connector space, which is managed by its corresponding management agent. The connector space is essentially a mirror of, or at least a version of, the related data source, with each object in the data source having a corresponding entry in the connector space. The connector space does, of course, not contain the source object itself. It contains a subset of the object's attributes, the ones we're interested in, as defined by the MA. MAs are primarily configured by setting their properties within a wizard-like interface in the Synchronization Service Manager. There are occasions when more complex operations are desired than those possible to the user interface. In these cases, an MA can be augmented by a DLL extension, produced typically using Microsoft Visual Basic.NET or C#. During development, MAs are executed via the user interface. In production systems, it's desirable to run the MAs in some kind of sequence without user intervention. This could be on a scheduled basis or in response to some external event. Automated execution of MAs is achieved using the WMI interface in conjunction with some kind of scheduling agent. FIM ships with a number of standard MAs, notably databases, SQL Server of course, but also Oracle and IBM DB2. There are several Active Directory-like MAs. There's one for a regular domain, also for LDS, or Adam as it used to be, and there's a GalSync MA specifically for doing global address list synchronizations. Other directories are covered, such as IBM Directory Server, Lotus Notes, Novell eDirectory, and so on. Then there are the file-based MAs, which are used when we can't connect directly. There's also an SAP MA, and then there's the Extensible Connectivity MA, which can be used to extend to other types of source. And these can become quite sophisticated, and there are many examples available from vendors or free on the web. For example, there are mainframe ones, there's MySQL, SharePoint, other approaches to SAP, and so on. Here's a simple architecture diagram for the synchronization service. Notice that it runs as a Windows service. It of course has its MAs to connect to various data sources, and the synchronization service data is stored in SQL Server. The Synchronization Service Manager, the administrative client that we use for configuring it and so on, connects to the synchronization service, but we can also use an administrative script via the WMI interface. Note that although it's a state-based system, it is able therefore to respond to external events through WMI control. There's an MA controller that controls the interaction between MAs. For example, if some data is imported by one MA, it'll be necessary to trigger the action of other MAs for export. There's a rules engine that enforces defined rules on various objects and attributes, such as attribute flow and precedence. The synchronization engine ensures that there's data convergence between the metaverse and the data sources. It handles each object in the form of a SQL Server transaction. If there are errors in any part of the update, the entire transaction of that object can be rolled back to preserve consistency. It also, of course, handles any errors, and an important job is that it resolves references between the different objects. The store layer communicates with the database and ensures data integrity. Let's now consider the information flow within the metadirectory, and to do that let's use a simple initial load scenario in which somebody called Susan Fine is represented in two data sources but not yet in a third, and not in the metadirectory. The process of how our information flows between the data sources and the metadirectory could be configured as follows. Note that this is just one possible scenario to demonstrate a few principles. The data in the two sources is slightly inconsistent. This is deliberate and typical of a real situation. The MA for the first data source imports and creates her entry, including attributes, in the connector space. This is called staging. It is also called import, but this can mean the entire import all the way to the metaverse, so for clarity we tend to use the word staging. The MA for the second data source does a similar job. Depending on how the rules have been configured, one of the MAs projects a new entry into the metaverse. That is, it creates a new metaverse object that corresponds to a CS entry. This CS entry is now termed a connector, since it is logically connected to a new metaverse object. Until this point it has been a disconnector. Notice that the second connector space object is still a disconnector at this point. Attributes may also flow depending on the rules that have been defined. So attributes flowing in this example are display name, full name, title and employee number. This has not actually been shown with an arrow just to avoid some clutter. Again, depending on how the rules have been configured, the second MA attempts to match this entry with a corresponding entry in the metaverse, in this case using the employee number which is conveniently available. This action is called a join. Such CS entries are now termed connectors. Had it failed to find a suitable match, or had the rules simply not resulted in a join, it would persist as a disconnector. Clearly, where possible, some unique attribute is used as the criterion by which entries are joined, employee number in this case. Equally clearly, it's not always possible to do that, so other approaches are possible, such as soft matching of some kind or just straightforward manual joining. At this point, Susan Fine is represented by an entry in each of the data sources, by two entries in the connector space, and also by an entry in the metaverse. Note that during the join, no object flow took place as such, but attributes may have flowed, again depending on how the rules have been set. In this case, the email and the name have flowed. Again, this flow is not actually shown with an arrow. As well as inbound attribute flow associated with the join, there may be outbound attribute flow according to the attribute flow rules you've defined. In this case, we'll say that the display name flows correcting the inconsistency that we previously had with display name. In general, where the same attribute could have been provided by more than one source, like display name in our example, one is chosen as authoritative, or several are allowed to be authoritative, but with an order of precedence. When the MA is next run in export mode, the attribute will be flowed to the data source. Whenever a metaverse object is created or changes in some way, any defined provisioning logic will be applied. In this case, a new CS object is created in that part of the connector space associated with the third MA. This is called provisioning. If there are outbound attribute flow rules defined, attributes will flow. In this example, email and employee number as well as a suitably generated account name. When the MA is next run in export mode, the newly provisioned account, a new object, will be created in the data source along with its attributes. Now that the connections have been made, further attribute flow may take place. For example, there may be attributes in the third MA that can be imported and then usefully exported to the first MA. Looking at the diagram and bearing in mind that each CS or MV object is just an entry in a SQL Server table, FIM must store some kind of unique identifier in order to maintain the connections between objects. For each MA, a unique data source attribute is defined, such as employee number or perhaps a GUID or a unique database ID, and this is called an anchor. Each metaverse and each CS object is also given a GUID, a globally unique ID generated by FIM. These are used to define the connections between the connector space and the metaverse. The anchor in the case of a directory such as Active Directory is the distinguished name, and it is a sign of a strong relationship between the FIM Synchronization Service and Active Directory that you will see anchor under DN being conflated into a single term, anchor brackets DN, even when no DN actually exists. It may seem a complicated point to make at this juncture, but in the case of a directory such as Active Directory, although the DN does appear to be the anchor and is treated as the anchor and behaves as though it is the anchor, there is usually a more fundamental anchor that's handled under the covers, and in this case, in AD, it's the AD GUID, which allows DN renames to take place without anchor issues. So let's briefly summarize these concepts. We've talked about objects and attributes. Each entry in the meta directory is an object of a specific type, for example, person, and it's comprised of a number of attributes, for example, display name, title, department, and telephone number. Examples of other object types are computer, group, and organizational unit. Note that while object types are similar to LDAP object classes, they do not exhibit inheritance, and an object may only be of one type within the meta directory. Attributes come as different attribute types too, such as string, binary, or boolean, and for each object an attribute has a particular attribute value, or in the case of a multi-valued attribute, of course, a set of values. The external sources of data for FIM are referred to collectively as connected data sources, or just data sources, or even just sources. The data flow between the FIM synchronization service and specific data source is defined in a management agent, and data flows only when a management agent is run. There's actually just one connector space, but each MA has a logical division of the connector space, an area in which it stores its holograms, from which changes in the data state are calculated, and in which pending imports and exports are staged on their way from and to the respective data sources. An MA may handle all objects in a data source, or may be configured to deal with only a subset of objects and their attributes. Every object and attribute from the data source handled by an MA is represented in the connector space. The metaverse is a collection of objects and attributes that hold the combined data of objects of interest in the data sources, and the MA configuration defines which objects and attributes are synchronized with the metaverse. When a connector space object is connected to a corresponding entry in the metaverse, that is called joining. If an entry in the connector space should be represented in the metaverse but no corresponding entry can be found by the join process, a new metaverse object may be created. This is called projection. Following projection, the connector space entry will stay connected to the new metaverse object. The same applies to joining. Each object in the connector space is either connected to an object in the metaverse or it is not. If it is, it's referred to as a connector. If it's not, it's referred to as a disconnector. It's worth mentioning at this moment that there's a special kind of disconnected object, a placeholder. Suppose that you import an object which has a reference to a second object that's not present. For example, an AD user pointing to a manager that's in another OU entirely that doesn't happen to be managed by FIM. That second object will be invented as a placeholder in order to maintain the reference correctly. If the second object is subsequently imported, the placeholder is simply replaced by the real object. You don't have to worry about placeholders. This is an internal thing, it's just that you might notice them. Each Metaverse object, and for that matter each CS object, is identified by a unique GUID. The connection between a connector space object and its corresponding Metaverse object is achieved using GUIDs. Similarly, there must be something that links each object in the data source to its corresponding object in the connector space, and that is an anchor. For some MAs, you'll choose a unique attribute or combination of attributes, but others it'll be chosen for you. Once a connection's been made, data source to connector space, to Metaverse and back again, attribute flow can take place according to define attribute flow rule. Each object in the Metaverse generally represents entries in more than one data source. It's possible that each attribute value could be provided by more than one of these data sources. In other words, multiple attribute flow rules may exist for each attribute. In general, then, there may be a conflict of attribute values. Therefore, it is important to understand which rules have authority, and where there is more than one, which rule takes precedence. The rules in FIM will be governed ultimately by business rules, which arise from an understanding that comes primarily from discussions with the business owners of the various systems. Generally speaking, will require that when an entry is found in an authoritative source like an HR system, that we'll want to provision entries into other sources such as Active Directory. So we have provisioning, but we also have deprovisioning. We need to make sure that equally there are rules for deciding when to remove objects as well. Lesson 2 covers the Synchronization Service Manager, and in particular the Management Agent tool, which is arguably the most important tool it provides. It covers the configuration of MAs and run profiles, and considers the MA statistics and errors that it reports. The Synchronization Service Manager provides 5 configuration tools to aid FIM administration and operation. All the synchronization service data is stored in a SQL Server database. The identity data and the configuration data, Metaverse, Management Agents, and all the statistics concerning past Management Agent runs are all stored in this database. This architecture, keeping all the information in one place, allows for straightforward backup and restore of the system, of which more later. The Synchronization Service Manager must run on the same server as the synchronization service itself. If remote administration is required, it can be performed by using remote desktop from a remote location, or to a much more limited extent, you could use the WMI interface. It is possible to export and import the entire server configuration to an XML file. You can do this using the options on the File menu, but as a matter of interest there are separate utilities to do it as well. This exports the Metaverse design to a file called mv.xml, and each MA configuration, including run profiles, to files called MA and then the GUID of the MA.xml. This might be done, for example, in order to transfer a configuration from a test system to a production system without including any identity data. I say that because you could just export the entire database and import it and get the configuration and the identity data. You'd also use this for any separate analysis, for example, by some external documentation tool. Note that during FIM installation, several security groups are created, which can be used to limit a user's access to the tools. A relatively low-level administrator responsible for monitoring the running of the server, but not in a position to modify the configuration of the server, would be assigned membership of the FIM Sync Operators Group, granting them access to the operations tool only. Members of the FIM Sync Admins Group have full access to all tools, and members of the FIM Sync Joiners Group only have access to the Joiner tool. Within the Synchronization Service Manager, in the Management Agent tool, there are a number of actions. You can create a new MA, look at the properties of an existing MA, delete it, and so on. The easiest way to explain this is through demonstration. This is what the Synchronization Service Manager looks like right out of the box. In other words, absolutely no configuration at all. You'll see that it has 5 tools: Operations, Management Agents, Metaverse Designer, Metaverse Search, and the Joiner. We're going to focus first of all on the Management Agents tool. And you'll see the various actions down the right-hand side that we could perform, many of which are grayed out until we've created our first management agent. We could import a management agent if we'd previously exported one, perhaps from somewhere else, but we haven't got one. So by way of an example, let's import some HR data. We'll create a simple HRMA for our pretend HR system. Now, you've already seen the HR system if you've done the previous module. So here it is as an application. But actually what underlies this is simply a database. So let's open up SQL Server Management Studio. So we're going to connect to the database engine. And let's maximize this. Expand the databases. And amongst our databases are the FIM Service database and the Synchronization Service database. These are the 2 databases that are used by FIM. But for the moment, we're going to import from a new source. It's HR data, and we've got a table called Table HR. If we just take a look at that, you'll find it contains very ordinary HR-like data. So we've got columns like, well, there's a staff ID or employee ID column, presumably some kind of region. Then we've got title, first name, middle initials, surname, whether they're active or not, the department, job title, and so on. One that stands out is Manager. You'll see that Manager here is a reference to the staff ID. So the way that we find out somebody's manager is by following to their staff ID and finding the appropriate row. So we have a reference attribute there. Actually, we won't be importing this table. Instead, we'll be importing a view. And we'll see that there is a view here called VW Staff. And if we look at that, we'll find it looks exactly like the other data. And in fact, it is exactly like the other data. But it's always useful to use a view rather than a table, because it allows you to provide a where clause if you want, or provide different columns, or even to rename the columns if that's useful. In other words, it provides a layer of abstraction between the underlying table and what FIM, what the synchronization engine, sees. And that just means that if the underlying data changes for any reason, or if our requirements change, we can simply make a change to a view without having to re-engineer the table. Okay, we're going to close this now, go back to our Synchronization Service Manager, and create a new management agent. Now, what will happen is that we're taken through a sort of wizard with a series of pages, and the first thing we're going to do is choose the type of management agent, and that's going to be SQL Server. Next, we'll choose a name, HR Data. It's important that you choose a name that's meaningful and stick to it, because there are places within FIM where that MA will be referred to by name rather than by any kind of GUID, and so it's a good habit to get into, to choose a name and stick to it. Use the description to deal with things like version control and so on, but leave the name as it is. The different pages that you go through will vary somewhat depending on the type of MA. But broadly speaking, we have to connect, we have to understand a schema, we have to have a way of choosing the subset of data that we're interested in, and then we have a set of rules that we configure which are the same for all MA types. Well, all except one. There's a special MA, the FIM Service MA, which stands out, but with that exception, all MAs are the same for the last 5 steps. That's from configure filter through to configure extensions. In the case of a SQL Server, we're going to connect to the local version, so we might put a server name in here, but localhost will do in this case. We're going to tell it the database that we're connecting to. This is HR data, and the name of that view that we're going to use, you might remember that that was VW staff. We also need credentials for connecting. We're going to use the administrator credentials for simplicity, but the point should be made that in general you would choose credentials that give just enough access and no more than is absolutely necessary. So I'm putting in the password and the domain, which is a datum as it happens. So we'll always have to connect if it's a call-based MA. If it's a file-based MA, we don't connect. The equivalent step here is that we provide a template file which allows the system to understand the schema. But in the case of SQL Server, it's a server and database, a table or view, and credentials. In the case of a directory like Active Directory, we would provide some combination of forest, partition, server, port, and so on. Notice that there is some optional connection information here which we won't make too much of, but suffice it to say that we're looking at a two-dimensional table at the moment, a straightforward table with all the data in it. If we were able to produce a table, a different table that had just the changes in it, we'd provide the name of that view as the delta view. And if we had multiple values, and that can only be held in SQL Server by having yet another table, we'd provide the name of that table as well. But we have no multi-value attributes, and we don't have a delta view in our simple HR system. So we're going to connect. So now FIM has been able to, or the Synchronization Service anyway, has been able to read the schema. For something like Active Directory, the schema is very well understood. For something like for a file-based MA, reading a file may not give a complete picture of the schema. We may have to do quite a lot of edits in order to get it to properly understand the length of each string, the type of data, and so on. For example, something like an employee ID might consist of numbers and would therefore perhaps be assumed to be a number, whereas it's not. It's a string of characters, and it should be treated as a string of characters. On reading a SQL Server schema, there's no problem with that. It's got all the types, but there are still one or two things we can do. For example, if we scroll down to our Manager attribute here, you'll see that it hasn't been understood in any special way. But if we edit it, we can make sure that it's understood to be a reference. And what that means is that it's a reference to the anchor which we're about to choose. So that's a reference and a reference to the anchor. Notice that there are one or two other things here to do with support for empty strings and nulls. It's important, on import at least, that an empty string is generally interpreted as a null. The two things aren't the same in SQL Server, and you normally expect an empty string to be treated as a null. Nulls are very important because they're used in precedence. If two sources could provide an attribute value, and one of them's precedent, it's going to win. But if it presents a null, the other one can win. If it's your intention that an empty string be interpreted as a null, it's important that you say so here. Next, let's choose the anchor. Had this been a table with a primary key, the anchor would have been guessed at. But it wasn't able to do that, so we're going to tell it that the anchor is staff ID. We can rely on staff ID being unique, and so we're going to use that. Finally, we can specify the object type here. And by default, the object type is assumed to be person, and that works perfectly well for us. We can change it to anything we like. We could also have specified it as part of the data in a column, but that isn't the case here. You'll see that there are additional buttons which would have been used had we provided a delta table or view, and also had we had a multi-value attribute anywhere. So we'll click Next. The additional step of choosing a subset of data in this case for this kind of MA is implicit really, because we've provided a view that contains the data that we want to present. In the case of Active Directory, at this point we could have chosen the object types and indeed the domain partitions and the OUs and the object types and the attributes that we wanted. But here, and in the case also of a file-based one, it's a matter of presenting the right data to the synchronization service. Now you could make use of this filter here to further restrict the data if you wanted to. But that's not really the proper use of a filter, which we'll go into later. And it should be obvious anyway that it's more efficient to only present the data in the first place that you want the synchronization service to have, rather than presenting to it and then further filtering it out later. But you could at this point provide a filter. We won't. We'll move straight on. Next, we have to configure join and projection rules. Generally speaking, and as a matter of good practice we will say always, you should provide some kind of join rule. Even if there's nothing in the metaverse to join to, which there isn't at the moment, you still provide a join rule just in case anything breaks and it has to be fixed later. So let's start a new join rule, and we'll choose we'll choose staff ID from the data source to be matched with employee ID in the metaverse. Remember that the metaverse has a common schema shared throughout, whereas each data source will have its own schema. So we shouldn't be surprised to find that there's a mapping of attributes going on here. It's essentially the same data. It's just that it might have different names in different systems. And we're making a simple mapping. We're saying staff ID must match employee ID. You'll see there is something more complicated we could do with a rules extension, but we're not going to do that here. Let's add this as a condition. And we're reminded that it would be a good idea if we were to index employee ID, because that will speed up joining, and we must remember to do that later on. Now we could have further conditions which have to be met for this join rule, but that's good enough. So we have our join rule. We can expand this and see what it is, and you'll see that you could apply further join rules. And the way these work is that it runs through the join rules in order until one's successful. If none of them are successful, it will finally, and it is always finally, apply a projection rule. In our case, we're simply going to say that every time a person's found, assuming that there's nothing existing to join to because nothing's broken and needs fixing, that we will simply project a person object in the metaverse. There are different object types in the metaverse that we could use, but person makes sense. Again, there could be something more complicated in the form of a rules extension. So what this is telling us now is it'll try and join to an existing object using staff ID. By the way, we said any object, and really, strictly speaking, we should restrict that further by saying it should only be a person object. So let's do that. So a person object in the metaverse, but failing that join rule, it'll apply the projection rule and create a new object in the metaverse. Having specified join and projection rules, we can move on to attribute flow. Much of our attribute flow is likely to be very simple, a matter of just flowing something like display name to the corresponding display name in the metaverse. We won't always have the same name. Again, we'll have mappings of attributes, and we're flowing from person to person, but these are direct flows. There are other kind of flows, but we will need to enter a few of these first. So let's click New, and that's a new import flow. So here we've added a load of attribute flows. What you flow in will be driven by your design. You'll notice that most of them are pretty straightforward, and many of them have the same name, in that the mapping doesn't involve a change of name. Notice a few of them in particular. We've flowed display name to display name, but we've also flowed display name to account name. Now, even though that's redundant, because obviously we don't need the same data twice in the metaverse, it is often useful to have an attribute in the metaverse that's populated even though you haven't got anything particular to populate it with at the moment. In other words, account name might have a different value in future, and it might be useful for us to distinguish between display name and account name. But right now, all we've got is a display name, and we're going to flow that instead. If we scroll down, you'll see that as well as the direct flows of attribute to attribute, just regular string attributes, there is the manager one. So there's a reference attribute flowing. We've had to map staff ID to employee ID. Notice that we are flowing that. If we don't do that, then the join rule that we've put in can't work in future. We're going to add an addition here, which is we're going to flow something into the domain. Now, we haven't got anything to flow, so we're going to make it an advanced flow. And when we click New, we can select amongst the options, one of which is a rules extension, a coded rule. We'll choose constant, and we'll just simply flow a constant value, the value of the domain that we like for everybody, into that. Notice that you can also, if you've got one, pick up a particular component of a distinguished name. So if you had a distinguished name like CN equals hue, OU equals a datum, DC equals a datum, DC equals com, we could choose one of those components like hue or a datum out of that and flow it in. But we haven't got anything in this case. So we're going to make that a constant flow, and you'll see that that's shown as a constant flow to domain. So we weren't making use of the source at all in that particular case. Those are all our attributes, so that brings us to configure deprovisioning. When a non-authoritative source object becomes disconnected from the metaverse, perhaps because some policy dictates that this should be the case, it must be either deleted or simply left disconnected in the source. An exclusive disconnector is one that will subsequently never be involved again in synchronization, whereas a disconnector, a regular one, could rejoin depending on the circumstances. You can also define a rules extension to perform something more complicated. You could have an additional task such as disabling or moving an account. These HR objects are authoritative, and so there isn't going to be a question of them becoming disconnected. It's them perhaps that's going to do the disconnecting if they ever get deleted. So in this case, we'll accept the default as is. Now there's nothing we need to do on the last page, and so we won't cover that just at the moment, and we'll finish and create our first management agent. Now before we can use that management agent, we'll have to configure some run profiles. But let's first of all note that if we'd made a mistake or if we needed to make a change, we'd use properties. And that takes us basically into the same wizard, allowing us to go through and make any changes that we need to make. A new attribute flow, for example. We could also delete it. If you do a delete, you can either delete the entire thing, which would be very unusual and quite destructive, but sometimes you just want to delete the data associated with it. Now in production it would be odd to do that, but when you're testing and developing, it's often useful just to clear everything out and start again, because perhaps the data's got into a bit of a state because of changes that you're making, and you just want to clear it, start again, and check that everything loads okay. Alright, let's configure a run profile. So we're going to have a new profile, and one of the profiles we're going to need is to just do a simple import. This will be a full import from the HR system. So we give it a name and we choose a step type, and you'll see it's defaulted to full import. But we could be choosing a delta import if these were allowed, which they're not in this case because we haven't configured it. We could be choosing a delta synchronization. That's a regular synchronization that you'd normally use. A full synchronization is used when you want to apply new rules to old data. More about that later. And also later we'll be making use of export as well. Then there are some combinations. Full import and delta synchronization is really the same as doing a full import followed by a delta synchronization. It's just a convenience to only define one step instead of two steps for a run profile. So this one's going to be full import stage only, and you'll notice that there are a few other options. But at this point, we're not going to make use of them. So we'll click Next. This last page actually turns out not to have a purpose for a SQL Server MA, but it's a page that's generally here. In the case of an ADMA, an Active Directory MA, you'd actually have the partition name, that is the domain name here. Let's click Finish, and we've created our first run profile. Notice that you can add further steps to a profile, or, as we actually need, you can have other profiles. So I'm going to create another profile called Delta Sync, and choose the step type Delta Synchronization. Again, I'm not going to worry about the other options, and later on we will need further ones of these, but this will do for now, and so we'll click OK. We've got our two main runs that we need right now. Now we're in a position to go straight ahead and perform one of these, so let's do a run and a full import, and this will be the very first time that we read data from our source. And that's going to present some statistics, and I'll rearrange the screen a little bit here so that you can see those statistics. And you'll see that there are 61 adds. It's discovered 61 objects in the table and it's imported them. Notice that the 61 adds is presented in the statistics in the form of a hyperlink. So it is actually possible for us to go and look at what's been added. We'll make more of this later, but just briefly, if I click this and then choose one of these anchors and double click it, we can see that what we've got is a pending add, a pending import of the add type. And here we have some new values that have been discovered for one of our users. And that's waiting to be synchronized. If I close this, I can do the other kind of run, which will be a delta sync. What that's done is to take all the connector space objects, which were disconnectors, and synchronize them, applying the rules, and in this case ending up projecting them all. So we've got 61 projections, and we've also got 61 flows to go with those projections. If we click on any of these, we'll see the same thing. We choose one of them to have a look at it. You'll see that it's now not pending, it's not, it doesn't say import, it doesn't say add. This is in its normal state. It's been synchronized, it doesn't need anything doing to it, and it's simply telling us that we've got a connector space object. If we go to the lineage tab, we'll see that it is a connector and it is connected to a Metaverse object. It's possible to look at that Metaverse object as well. And now we're looking at a Metaverse object where we've got the attributes, the value in the attributes, and also which management agent contributed the value and when. More on these dialogues later. But what we've got now is, as a result of our import and our synchronization, is we've got an MA with some objects and some objects in the Metaverse. Now before we leave the Management Agents tool, let's note that there are a few other options here. We've seen run. We could stop a run that's going if it was taking a long time. We can also export a management agent from here. That'll write the configuration, including the run profiles, out as an XML file. We could import it. So that would be a way of migrating an MA from, for example, from test to production. I'd export from test, import to production. Or if I had an update that I wanted to migrate, I could export from a test system and update an existing MA in a production system, for example. Also, sometimes you need to refresh the schema. You do this because the schema's changed in the source. So if the schema changed in our view, in our HR system, we would need to refresh the schema. We'd then taken through the wizard again as appropriate to allow us to configure for any changes that have happened. You can also search the connector space from here. We'll make more of that later, but just to look at it very simply, if I take search connector space and search, I get a full list of all the connector space objects. There are many search scope options which we won't go into just yet. We can also create extension projects, but that's well beyond us at the moment, so let's not worry about that one. So in that demo, we configured a SQL Server management agent. There's actually a lot in common between the different types of management agent, but there are also some differences. And the information required does depend on the connected data source. Generally speaking, there'll be a way of connecting to the data source, understanding the schema, and you'll remember that we made a few edits to the schema once it had been read. In the case of Active Directory, you wouldn't be able to make any edits because it's completely understood. In the case of a file-based one, there might be quite a lot of changes that you need to make. Notice that file-based ones have another difference, which is that rather than the schema being read, which of course it can't be, we provide it with a template file, which is typical of the import data that it'll get. There may be other configuration requirements, such as choosing an anchor, or specifying reference attributes, specifying the way that deltas are to be handled, and so on. We also need to, in general, select a subset of data. For SQL Server, it's a matter of presenting the right view. For a file-based MA, it's a matter of presenting the right file. For Active Directory, we choose the domain, OUs, object types, and the attributes that we're interested in. If you want any further restriction, that can be done through a filter. Once we've connected, understood the schema, and identified the subset of data we're interested in, there are a number of steps which are the same for nearly every MA. And the primary steps are to set up a join rule, which should always be done as a matter of good practice, a projection rule, if this is an authoritative source for objects and is actually going to project new objects into the metaverse, and then attribute flow. And we saw that there are different kinds of attribute flow, although many of them may be simple, direct attribute flows. We also had to decide what happens should the object be disconnected. Although we noted it in the case of our HRMA, it's authoritative, and therefore it's more likely that it'll do the disconnecting rather than that it'll get disconnected by something else. We also noted that it was possible to have rules extensions, although we're not covering those here. And finally, that it might be necessary under some circumstances to refresh the schema. We did also create some run profiles, and we noticed that they were made up of combinations of import, synchronization, and export, and also that there are delta and full. The normal type of run is going to be a full or delta import, followed by a delta synchronization. Full synchronizations are only normally used during testing and development to apply new or changed rules to old data. Whether a delta import is available depends on the MA. In the case of Active Directory, it's going to be available. In the case of SQL Server, it's only going to be available if you do some extra work to configure it, and then other systems may not even provide the possibility. A run profile is made up of one or more steps, and the steps can be combinations of those modes, or they can just be single steps. An MA will generally have a lot of run profiles. It'll have the run profiles that we use just in day-to-day running, and then it'll have other run profiles that we typically only use for initial load and disaster recovery and so on, or possibly some kind of overnight update. Remember to name your run profiles sensibly, just as you have your MAs sensibly, because they're going to be referred to in scripts. Run profiles are part of the MA definition, so if you export an MA, you export the run profile definitions too. Also in the demo, you saw some MA statistics and errors being reported. Actually, hopefully no errors. The Management Agents tool gradually displays available statistics as a run takes place. The information includes the step type, start time and end type for the run, where multiple partitions exist, for example in multi-domain Active Directories, which partition was synchronized, and the status, success or failure. And then there are statistics such as well, for staging, that's the import part, how many of the CS objects were unchanged, added, updated and deleted. In the case of an LDAP type source with distinguished names, there might be renames as well. For inbound synchronization, how many CS objects were projected, joined, had attribute flow updates, were processed but did not have attribute flow updates, how many disconnectors, how many resulting metaverse delete, and so on. Outbound synchronization, which we haven't seen yet, reports the number of export flows and other outbound actions. And then there is the possibility of doing an export run, which again we haven't done yet, which, perhaps not surprisingly, reports the number of exports actually sent out to the source, add, update, delete, and where DNs are used, renames too. If an error occurs during a step, an entry for each object in error will appear in the error pane on the right. There's an error limit set to 5,000 objects, although this is actually configurable in the registry. If a step encounters 5,000 errors, the process will stop. Most error messages and statistics are in the form of hyperlinks to further details, including properties dialogues. The MA statistics stay in place until another run by the same MA, but the operations tool, as you'll see shortly, can be used to view statistics for previous runs. There's one other thing, that on the Tools menu there is a statistics option that gives overall statistics for all MAs. For example, total objects, total connectors, total disconnectors, and so on. Lesson 3 briefly introduces the other 4 tools that come with the Synchronization Service Manager. While the Management Agent tool shows the information about the most recent MA runs, the Operations tool provides a history of previous runs. The information available for each run is very much as given in the Management Agent tool. Additionally, from this tool you can run an MA, stop an MA, save the run history to an XML file, and clear runs, optionally up to a date that you provide. This last action is very important because if you never delete the run history, you will eventually run out of disk space. It is usual to clear runs on a regular basis, whether here or through a script. Remember that if you view an older run of an MA, you'll see a list of anchors or DNs. However, the properties of the object are the current properties. If the object has changed since that run, only the current state's available. In other words, it keeps the statistics, but it doesn't keep a complete copy of the state of every object at that time. And of course, you might be looking at a history from weeks ago and an object that's current. The FIM Sync Operators security group, created during the installation process, can be used to provide users with access specifically to this tool. Operators can run and stop MAs, review the run history, save a run to a file, and clear the history of the runs. Let's take a look at the Operations tool. You'll see it's showing 2 runs, the 2 runs that we did just now. If I select the full import one, there are the 61 adds that were reported. If I select the Delta Sync one, there are the other statistics, 61 projections and 61 flow updates. Contrast that with what's currently showing in the Management Agents tool, which of course is just the latest run. So we see the latest statistics here, but in the Operations tool we see the history. I can still click through the hyperlinks and look at any of these. We have to remember that we're only ever looking at the current ones. So there we see the current state of that object. Note that amongst the actions here I can clear the runs, and I can clear them before a date or clear all runs. I can also save the runs to an XML file if I want to before clearing them and archive them off somewhere. Clearing runs is very important, otherwise the history file will just get bigger and bigger and bigger, and it does occupy quite a lot of space. Notice that if we go to Tools, Statistics, we can get further statistics for the MA. This is the total number of objects of different kinds, and also the total metadirectory object count. 61 connector space objects plus 61 metaverse objects makes our total metaverse count. The Metaverse Designer Tool allows you to extend the schema, which is not something we're going to be doing. So let's just say that the default schema includes a lot of object types and attributes, and that's all you're going to need for this course at least. But you can configure attribute flow precedence. Sometimes more than one source can provide a value for a metaverse attribute, and you need a way to decide between them. For each combination of object type and attribute, you can define an order or choose equal precedence. There's also an option for manual precedence, for which you must provide coded rules extensions. We won't attempt to explain all of this here, but the purpose of it will come out during later labs. You can also edit attributes just to the extent that you can index them, and you'll remember that that's something that we need to do for our employee ID for joining purposes. Here you also configure an object deletion rule. Metaverse objects are only ever deleted as a result of a CS object being disconnected. In other words, because a source removes the object in some way, perhaps by an actual deletion. Put another way, whenever a ConnectSpace object disconnects from a Metaverse object, the question arises, should the Metaverse object be deleted? That question will be answered by looking at the Metaverse object deletion rule. Here are some reasons why a ConnectSpace object might disconnect. Because ConnectSpace object got deleted, a deletion was imported from the data source. Because a filter action disconnected it, for example, the filter status equals terminated. So now you begin to see what the connector filter is really for, that could trigger deletion then of Metaverse object, or a manual disconnection. If the connector space object originally projected this Metaverse object, that is, it was authoritative for its creation, then it may well make sense for it to trigger deletion. That is, it should be authoritative for its deletion. This will not always be true, and Metaverse deletion rules can be complicated. They can even be coded in a rules extension. But in a simple example, like just our HR system, the chances are it is going to be authoritative for deletion. But as a slightly more complicated example, it may be that two systems can project Metaverse objects, perhaps the FIM service and the HR data MA. It would be typical, therefore, for these to be selected, as in the diagram that you can see. By the way, there's a default behavior in FIM that a Metaverse object will be deleted when its last connector disconnects. Whichever of these options you take on this dialog, you cannot switch off the default behavior which ensures that you do not end up with an orphaned Metaverse object. Let's take a look at the Metaverse Designer. You'll see there are a number of actions we could do in the way of schema additions and modifications. We can create new objects, delete an object, we can copy an object type, and we can add attributes. We're not going to do that here, but we will just focus on person here and see that we could choose an attribute such as employee ID. We can edit that attribute. Now actually the only thing we can do to it is index it, which funnily enough is exactly what we require here. That will speed up the joining process for any new imports. Still focused on person, we could go to the object deletion rule, and you'll see at the moment there's not a lot to do. It almost doesn't matter which of these options we take because there's only one type of connector space object, and that's from the HR data MA. Whenever an HR object disconnects, it will definitely lead to deletion of the Metaverse object. But we might just do this, and select HR data to make it explicit that that's the choice. One final thing is that in general, if we look at a particular attribute, and again we could take employee ID as an example, we can configure precedence. Now there is only one MA providing a value at the moment, but we can see that if there was more than one, we could change the order and specify which one was precedent. Or we could specify equal precedence, which is really a free-for-all, last to right wins. The Metaverse search tool is used for listing objects in the Metaverse and then examining them. Once you have your list, you can view the properties including Metaverse GUID, display name and object type. In fact, all non-null attributes will be shown along with their value. And along with the value you get which MA contributed it, the attribute type, and when it was last modified. Any references become hyperlinks that can be used to bring up the properties for referenced objects, such as a person's manager. There's also a connectors tab that gives a list of connectors along with the anchor value, or DN, the join method, and so on. And you can view the properties of these too. In fact, you can also disconnect them from here, deciding as you do so whether to make the CS object a normal or explicit disconnector. Until you're very sure you know what you're doing, don't do this. By default, the tool returns everything, and in a production environment, everything is unmanageable. So it is usual to define a query by configuring an object scope, what object type do you want, perhaps a collation order, and then one or more clauses, filter conditions such as given name equals Susan, so that you can find Metaverse objects of interest. And then once you've done that, you also typically specify the columns that you want to see, which attributes and other properties you'd like to see, and again in which order. Then finally you click Search. You can export and import queries so that you can reuse them. So here is the Metaverse Search tool, and if we simply click Search, we're going to get a default listing of all of our Metaverse objects. We have 61, you might remember that count from earlier. Generally speaking, this will be a very large number in a production environment, so it would be normal to scope by object type, saying, well, we only want persons at the moment, to add a clause, which is perhaps that display name starts with S for the sake of argument, which will give us a restricted listing. So we can configure column settings now and choose what we want to see. Let's include some obvious ones. We've got display name, so let's include employee ID, given name, surname. Where's surname gone? Surname. We'll also include manager, and we'll include object GUID. Let's now rearrange things a little. And it may not be obvious, but the manager is a GUID, which is a reference to the object GUID. And in fact, you can see that two people there, Susanna Stuberod and Steve Riley, are both reporting to the same manager, although we can't actually see which manager that is at the moment by chance. So what we see is that something that started out as a reference to the anchor, in other words, to the staff ID, has been translated into the correct kind of reference in the metaverse. If this got exported to Active Directory later on, we'd want that to be further translated into an Active Directory reference. That would be an Active Directory GUID. All of this is handled quite automatically. This translation takes place seamlessly within the synchronization engine. If we actually take a look at one of these, let's look at Susan here, we'll see that that manager GUID has now been resolved to a hyperlink, and we can actually click that hyperlink and go and see who the manager is. And you'll see that we can follow a chain if we want to here, until presumably we eventually get to the top of the company. Or, as has happened here, we've actually ended up in a loop. In other words, we've got an error in our data here, which, by the way, we threw in deliberately to throw up this kind of thing. We've got an error here of one person managing another person who manages them. So what we've done is reveal here an error in the data, which we'd have to, of course, go back to the HR system and fix. But you get the idea that we can follow a chain here and see the various objects. If we just go back and look at the original object here, we'll see that there is a connectors tab, which allows us to look back at the connectors for this metaverse object. There is only one, and it's the HR data management agent. We could even, and we don't want to do this, we could even disconnect them if we wanted to, specifying an explicit disconnector or a normal disconnector, which is the default. It's possible to save this query, so if we go to Actions, you'll see that we can export a query. If we do that, we'll be exporting the scope, the collation order if we want, any clauses that we've defined, and the column settings. That means we can then easily reuse it in future. Finally, in this lesson, the joiner tool. A typical FIM implementation involves joining of many objects, and this is not always, it cannot always be, no, start again. A FIM implementation involves the joining of objects from a variety of data sources using an attribute or attributes that they have in common to identify which objects should be joined to each other. But because real-life data is rarely perfect, the joining process may not be able to be performed fully automatically. Because real-life data is rarely perfect, this joining process may not be fully automatic, or indeed it may not be possible to do it automatically at all. Where there is ambiguity or missing data, you'll be left with disconnectors, CS objects that are not joined to a corresponding record in the metaverse. The joiner interface allows manual location of and joining to suitable matching metaverse objects for each disconnector. It allows you to list connect space objects for a particular MA and define a filter to apply to the metaverse to help you find suitable metaverse objects. You can also choose to project a disconnector manually if that's what you want. By the way, if you make a manual join, the connect space object involved does not become a normal connector. Rather, it is an explicit connector. This has the interesting property that a filter will not disconnect it. More of this in the next module. One extra feature of the joiner, and this is the only place you can do this, is that it allows you to change the status of a disconnector between normal and explicit. There is a specific security group for users who perform the task of joining, and that's FIM sync joiners. It limits their access to this tool and also to the Metaverse search tool. You're now ready to do the lab. We demonstrated some of the lab, but you'll be doing a few additional exercises.